Welcome to today's lesson. So today I'm going to do an introduction to work, potential energy, and kinetic energy. So let's start by work. So how do we find work? Work is the same as work is force times distance, where W is the work, F is the force applied, then D is the distance. So work should be work in joules. Work in joules. Then force should be newtons. Then distance should be in meters. So if you want to calculate work, you multiply force by distance. So work is the same as energy. So the SI unit of work is joules. Then let's move to potential energy. Potential energy. Potential energy. Now, potential energy is the energy possessed by a body which is stationary. Now, we have different types of potential energy. For now, we are going to look at gravitational potential energy, and elastic potential energy. Elastic potential energy. Now, let's start by the first one, which is gravitational potential energy. Gravitational potential energy. Gravitational potential energy. So, gravitational potential energy is the energy possessed by a body that is which is at some height from the Earth's surface. Yes, and it should be under gravitational field strength. Now, to calculate gravitational potential energy, you have to use the formula mgh, where m is the mass of the body or the object, then g is the gravitational field strength, and h is the height, the perpendicular height. H is the perpendicular height from the Earth's surface. So it's the perpendicular. This sign means perpendicular. So perpendicular height is the perpendicular height. Now, that's a gravitational potential energy. Now, mass should be in kilogram. the mass of the body should be in kilogram. Then gravitational field strength, Newton per kilogram. Then the height should be meters since it's distance. Then let's move to elastic potential energy. Elastic potential energy. Elastic potential energy. Now, how do we calculate elastic potential energy? So elastic potential energy, use the formula half ke squared. Half ke squared. So elastic potential energy is the energy that is possessed by elastic materials. Elastic materials can be a rubber band, a spring. Now, when a spring stretches, there is some work done, and thus the elastic potential energy, the energy used to stretch the spring. Now here, K is the constant. K is the constant. E is the extension of the spring. So extension should be in meters. Extension. So we've looked at potential energy. That's where we have elastic potential energy and the gravitational potential energy. And we have also looked at the formula for finding work. Now we are going to look at the kinetic energy. So kinetic energy that's possessed with a body in motion. So what's the formula for calculating kinetic energy? Kinetic energy. So for kinetic energy, use the formula half mv squared. Half mv squared, where m is the mass of the body in motion, so the mass should be in kilogram. Then v should be the velocity of the body, and the velocity should be in meters per second. Meters per second. And that's the end of this introduction of the work, potential energy, and kinetic energy. So just let's have a review or summary. So you said work done is equal to force times distance. Gravitational potential energy is mgh. Then elastic potential energy is half ke squared. Then lastly, ke, which is kinetic energy, is equal to half mv squared. And these are the formula we will be using. Thank you.